Hi everyone, my name is Daniel George and I'm a screencast for Project 2. So my implementation uses two standard list data structures, and the list library is essentially like a doubly linked list with a lot of the same implementations as a normal list or array in a language like Python, which is why I chose to use it. As well as that, it's also one of the ways, like in addition to a bitmap that was mentioned in the slides. So I stored two of these, one of these for the blocks and one of these for the holes. So with that, I had a block data structure storing the start address in addition to the offset and the length of words, which the whole also uses. So the reason we have start address is because we need it in the free function in our memory class. So now to talk about the code in the memory class itself, we have the constructor, which essentially just takes in the variables, passes them with the instantiation, and sets those to the class. Now we have the destructor, which essentially just calls the shutdown function, which I'll get into in a bit. And then we have the initialize function. First thing we do is check over some edge cases, and then if, say, like we have memory, then we'll call the shutdown function before we go here. I also want to call out that for the extra credit, I made sure not to use a new keyword. Instead, use the mmap function, which is it essentially asks the OS kernel for memory itself, memory block directly based on like the math that we do up here to get the total amount of bytes that we actually need. And then, yeah, from this point on, we also clear all our blocks and holes, and then add in the initial hole, being like the entire memory block itself. And now we have the shutdown function, so this is pretty much the opposite of initialize, since we use mmap for the extra credit. I'm using mudmap here, which essentially just gives memory back to the OS, and then we clear our holes and blocks and set the words to 0. Now we have the allocate function. It's one of the main ones. First thing it does is calculate the math to convert the size in bytes that the user wants into the number of words that we actually need. Then we should round up. Then it calls getList, gets the current holes, and then passes in the list of whatever allocator function we have, like setRandom, like best or worst fit. And if the allocator finds a spot, and it's like maybe it doesn't return -1, we loop through the holes and find that exact hole, and then we either erase the hole if it was a fit, like a good fit, or we just shrink it by like updating the offset and the length. Finally, I create an allocated block and then push that on to the blocks list and return a void pointer to the user. Now for the free function, my free function finds and erases the block, and then it does a sorted insert on the new hole into the holes list, and then once inserted, I check like the before and the after, and making sure that like if either of them are touching, then we group them together and then push that back on. And yeah, with this also like maintains the sorted functionality. Next we have set allocator. So this is just a simple setter. It sets the allocation function to whatever we pass in. Right? The dump memory map. The spec said we had to use pause call, so I'm making sure to use open to open up the file, and then I loop through my holes list, and then I use sprint sprintf to format the offset length string, and then I use write to put that string in the file, and then I make sure to add the separator. Finally, I use close, and I just want to mention that I did not use any extra here. Now we have getList is what the allocators use. It creates a new array at the heap. And then first element is the number of holes, which you can get pretty easily. And then also we loop through the holes and the offset, and then we loop through the holes and then get the offset and length for each one, and then we add that on to the array that we're building. Next we have getBitmap, which creates a vector of booleans, and we set them all to false initially, and then we loop through the blocks list and mark the words that they use as true, and then we create a new uint 8 array, and then the first 2 bytes are the size, which are in little endian as per required from the spec. Then we loop through the boolean vector 8 bits at a time, and then we pack them into like a single current byte, and then we just add that byte to the array. Get word size, super simple setter. It just gets the words, which is like what we already have stored in that class. Now we have the get memory start, which returns the beginning of the memory block, so it just like gives the address there. Now we have the get memory limit. This is the last getter. It returns the total size in bytes, which is just like the total size in words times the like word size and stuff. And then we have two allocator functions, which aren't part of the class, but they both take lists from getList and cast it to an unsigned short pointer, and then read the whole count. Best fit loops through it. That's the smallest hole that's big enough for the request. Worst fit does the same thing, but it just finds the largest hole. Now I'm gonna make sure so it's right there. And then at this point, I will just do the official test, and then at this point, I'm also going to do the val grind and show, so we got 38 to 38 for the test, and then here for val grind, no memory leaks, so we're good. Okay, thank you.